Alright, I'm going to be waiting for a couple of people to get on, I think. I'm 5 minutes early this time due to some of my technical difficulties I had in my last live stream, and it being almost 10 minutes late. But today, we are going to have some fun with a few more sets of boards. So, I am going to have I'll go over this again in a moment, but I've got 3 different boards we're going to populate today. I've got a bias and rectification board. I have a smaller power supply filtering board that will be for the 12 volts. It takes in the 6 volts from a transformer I have and converts that to 12 volts DC for the foot switching and relays. And then another one that will be the FET board. So we're going to try and put all those together today. We'll probably not get all of them done today, but hopefully maybe we will. So at any rate, that is the plan for today. I'm just going to be hanging here for a second. I do see a couple people joining, but I will be waiting until I get past my time. I just wanted to start the stream a little early today, so I've got a couple more minutes. I don't want anybody that was planning on being here right around 6 to miss the start, so I'll kind of cover that again in a moment. But I hope the people we've got on are having a good day so far. So give me a hey in the live chat. I should probably turn my soldering iron on. I'm probably not going to need it for a little bit, but one of the things that, since I've got a few minutes anyway, one of the things that I found out the hard way was I took a set of Dumble boards that were designed by some guys in the forum, and I tried to build these, and it turns out these are completely wrong for this specific Dumble. It's for some of the other overdrive specials that are out there. Maybe they're newer models, I don't know, but I kind of messed that up. So I rebuilt some today really quickly before this so that we've got them available. The only flaw I've got on this one is I missed an extra drill spot there. I gave it an extra drill spot because I just have to have the capacitor across there. This cap will go right across there. I also made that kind of long because I'm barely hooking the leads in, but it is going to make physical contact and stuff. Once I solder those in, we're good to go. Otherwise, I think we're almost to time now. So if anybody is on the live stream and wants to say hey while I'm waiting to get enough people here to start, please do. I also have some kind of cool news that I got today, an orange rocker Verb 50 that I will be working on and make a video later, but I'll be uploading that video after I finish the Dumble series, I'm sure, but so I'm kind of excited about that as well. Also, please feel free to throw in any questions into the chat. I'll try and keep an eye on that periodically to answer any questions that I do get. We are now 1 minute away from the time. At 6 when I said it'd start, so I will actually start here in just 1 minute. Today I did prep also all of my components that I need, hopefully to be ready to go. If you want to follow along, I will quickly show at the start of this. I've got some pictures of the, let me go back here. We'll hide that for a minute. So if you look here, we've got these 2 boards on the left that I'm going to be building first, and then all the way over to the right, I'm going to be building this board. Now, I'm not building it that exact way. Another thing I've found was that my space is much more constrained. This chassis I'm using is very thin. It's only about 1.75 inches roughly. So I'm going to have to be limiting my building to be able to fit them in a little bit narrower space. So I've kind of had to custom build those. But we will definitely get to that in a minute. You can see these are fairly thin because they need to fit in that same space. So I'll be doing that as well. All right. So I'm starting over really quickly for those that may be just about to join here now that we're hitting the 6 o'clock mark. I'm going to be populating 3 boards. I just kind of showed a second ago. If you want to follow along, these layouts are there's a thread in the Amp Garage that's all about the Dumble number 124. It has the layout, it has the schematics. But I've had to make some minor changes to these boards to make them fit into the chassis I have. So they're going to hold all the same components. They all have the same kind of lineup. But I've had to do some tweaking and adjusting to make that work. So hopefully that will work out for me, but you guys will learn with me as we go. So I'm going to go ahead then. Right now, this first board is the what's the rectification and the bias. So we will be basically taking two of the leads off of the transformer. We'll hook up into here, and then it goes through several rectified diodes, and then that will take off and go off to the power of the amp. Additionally, down at this bottom side, we're going to have one diode and one resistor and a filtering capacitor that will be doing the bias filtering. So I'm just going to go ahead and start laying in some of these diodes. So I need to put that in there. There's one. Hopefully everybody can see and hear well. I did a little bit more testing to make sure things were set up a little better this time, because last time I had some definite audio problems, or audio and video problems. I do now have constant power for my power supply for my camera, so that we shouldn't have any cutouts on that one as well. But yeah, so let's see. No chat yet. All right. So just building out the bias, or I mean the rectification and bias board first. We'll get that done, and then we'll move on. Now, one of the things that may seem confusing, and it was to me at first, is doesn't just two diodes create a rectifier for you? Why do I need, in this case, I'm going to be doing 6. It's a design feature to protect against faults. It is possible, although unlikely, but occasional, that a diode will fail short instead of failing open. That means it becomes a jumper wire. In that case, you have, instead of shooting straight full B plus onto your machine and potentially damaging things, or not your machine, but onto the next stages, the filter capacitors and whatnot, you instead guarantee that these other ones become a backup. And they can also run, you know, they kind of, in theory, roughly share the current going through them. So that also means that they also last longer and run cooler and all of that. So it kind of gives you multiple layers of protection. So that's why having more than one is a good idea. Another thing to know about diodes is the band is what they call the anode. That's where the positive side of your signal should go. And if you're trying to do the reverse type stuff, then you would want that to be at the other end. And similarly, it can be a little confusing on bias circuits that you actually reverse everything. So because you're taking the negative, you want a negative voltage. You actually kind of reverse the way things are set up. So, all right, so that's that part. Like I said, I kind of went ahead and got this guy set up as well, because it is going to be a little hard to get that to stay perfectly. Then we need a diode going the other direction. Actually, I do need a jumper here. Let me create a quick jumper. Between those two. It doesn't need to be very long. We're talking like that. Alrighty. So that will jumper, we're going to connect a ground off of this, or this actually goes into the bias because it's the negative end, and then this end, which is the positive end, as well, will go to ground. But let's see, the input actually comes in, though, in through this side here. So I will be connecting in one more diode in there really quickly. And then we will have a resistor as well. Alright, now that's going to be fighting me, I'm sure, a lot. And then finally, I couldn't find a 3.3K resistor anywhere, and I swore I'd ordered one, but I might have just been going off the fact that I had a couple of these carbon composite ones. Since it's the bias circuit, carbon composite, generally I don't like using them because they tend to be the noisiest type of resistor. Some people think that they create a little bit of warmth to the circuit. I personally don't. I think they create noise. But the resistor itself, in this case, is for the bias circuit, so it's feeding at the power stage, which is the highest output and lowest kind of noise sensitive stage. So I'm not as worried about it here, so I'm just going to go and use one that I had here on hand that's a 3.3K 3.3K carbon composite. Alright. And this one is just fighting me. So I will need to hook a lead up to, I'm going to give myself, I may actually have to think about this. I might leave this off temporarily because one side of it is going to be connected to this jumper and going off to the bias potentiometer. The other side is going to go to ground, I believe. Let me double check that really quickly. Oh yes, that does go to ground. So what I can do is I can solder on this positive end a long black lead that will be my ground connection. That way I can solder that in. So we'll go ahead and get that ready. I don't know how long it's going to need to be, but I'll give it some a decent amount of length. All right. Okie dokie. Let's see if I've had any comments from anybody. Oh, I see Philip Watson has messaged me. Yeah, that is absolutely. He just had him over at the garage. He's brought me an orange rocker burb I'm going to work on. So welcome to the stream, and that is one of the things that you guys will get to see a video of soon. Is me working on that orange rocker burb. He says it works. I'm possibly just going to be retubing it, but I'll also just give it a once over the circuit. We'll talk about the circuit a little bit and make sure that everything looks like it's copacetic. So we'll all get a chance to look at the guts of that thing when we're looking at it. So thanks for that. I'm going to look forward to doing that. So it's going to be fun. So. All right, so I'm gonna crank on my air filtering thing a little bit, but I'll try not to keep it on a ton because I know it makes a lot of noise. So. All right, there's that end tacked down. And I will quickly also, hopefully, you guys let me know if that's too loud. I might have to adjust a bit. I can maybe look at the software, see if it shows. Yeah, we're pretty loud. So I will quickly solder this and turn that back off so that it doesn't impact the noise too much. Hopefully that's not horrific to people watching, but I don't want to end up choking myself. So I'm not going to solder the tips here or the ends here because I need to bring wires in, but I am going to solder anywhere else that I can to make sure my components will stay in place. So I'll have to connect something into that guy as well, so we won't solder that yet. Oh, I'm getting my, hold on, I've got to get my soldering iron wrap from my multimeter. So the soldering process, people may not know, you want to get the solder tip wet so that it has better contact area, but then you want to kind of come in with the solder from the opposite side to guarantee that means the joint is well heated. And then we'll get well wetted so that it will solder. So, and you should kind of every once in a while clean the tip and get a build up of black goo, which is really the flux that you want to clean off as well. Soldering is something that took me a long time to get good at, and I don't think I'm amazing at it, but it does take practice. Alright, well, that's that board, done. One down. So what I'm going to do, I'm kind of letting that sit for a second cool off. And while that's cooling, I don't want to move it, because if you move the joint too much, it will end up causing it to get what's called a dry soldered connection. So these look silvery. A dry soldered connection will look kind of dull gray, and that means that it has a bunch of little fractures in it that over time will just get worse and worse, and eventually you'll kind of lose the joint. So those are kinds of things you want to avoid. So I'm going to take this guy out now. I'm going to quickly snip off all the bottom stuff, but you can see there it is. We'll bring in the high voltage here. It will be rectified across. On the output, I'll connect this off over to one of my first power filtering stages, and it'll be good. And then the other side here, this goes to ground. This will be my bias input. And this side comes in from a variable resistor that you can use with adjusting the bias. So I might have that backwards. Anyway, I can look really quickly. My screen to sleep. So I think from the bias tap of the transformer comes into here, and then this output goes to the actual bias resistor. So that is good to go. So what we'll do is come on this side now and get my snips out, and any of the ones I've actually soldered in, we can snip off and get rid of. The other ones will leave until we solder them. Alrighty, so I will end up connecting a wire to that eventually as well and soldering that in also. One of the things that I might have to try and figure out is I might snip these back a little bit. Actually, now that I think about it, I possibly will. Since they're already in place and locked and not moving anywhere, and I'll just be flowing solder into those with something else, I can snip them back a little bit like this. So they'll still hold into the hole, but not be a problem for the solder flow in and lock them into place, and we won't lose anything. So I've just kind of snipped those, and then we'll be able to drop in the other stuff. So another one done. Next up, let me just check if there's any other questions. Nope, just Philip give me the okay. And it looks like we're up to 6 people. Woohoo! Let's get the next board, and that will be the supply, the power supply for the, let me look at how I want this. This is the power supply that will go for the 12-volt relays. So this will have another separate power coming in from the 6.3 volt transformer I've got, which happens to actually be right here. So this guy will also connect into 120 volts. The output on the other side is going to be center tap, which I think we will ground, if I recall. If not, I'll have to check. I don't know if I grounded or if I just need to kind of close that off. But then the other 2 windings will connect in to, where is it? We're doing a voltage doubler, so I think one of them goes like into the center of one of the 2 diodes, the other goes into the center of these 2 capacitors. That creates a voltage doubler circuit. So then we'll get an output of about 12.6 volts. And it goes into a voltage regulator that then gives us a nice even 12 volts that will go out to the relays. Alright, so to start that off, I have the components for that here. And really the big guys, the capacitors I'll put on last because they're big and bulky and will kind of cover stuff. So we're going to start off with I've got the 2 diodes, and I will put those in. So a voltage doubler circuit is an interesting circuit. It's I don't know that I fully understand why it works, but it effectively you place the diodes in a way with the capacitors as well, so that they create a kind of you get both the positive and the negative on the bottom side together kind of at the same time, and I guess that causes them to double up or work together. You can also, though, create voltage quadruplers and even more by just repeating that kind of general pattern. So I'm definitely not an electronics engineer, so to me it's a bit confusing, but I probably should research it more myself. Alright, so there's the 2 diodes, and then we need, there's 2 1K resistors, and I've got those here, but as I've said before, I know they're supposed to be 1K resistors, but I also take just a second always to quickly test that. So we got this up. Yep, 1K. That one's 1K. We'll double check another one here. 1K also. Cool. All right. So those go into this top part right here, here, and here. So and what I will be doing with these, as well as what I've done with the other ones, is I will not be soldering the top ends because I'll be hooking some wires that I don't know how long they need to be to go off to somewhere else. I'll leave those unsoldered, but I will solder the back end once we get that in. And there's that. All right. So next, let's see, we need to put a couple of jumpers on, so I'll do that. I had a question. Specific soldering or heat that you would recommend. So I've got, this is a Heiko soldering iron that I have. A simple, basic one that's kind of a pen one that tend to cost like the $10 or $15, usually don't give you consistent enough heat. For simple soldering, they work, but they tend to be a bit of a pain in the butt. Having a nicer soldering iron like this, where it's my soldering iron has a base unit like this. You can set temperature. It also has the ability to sense that temperature in the tip itself. It wasn't cheap though. I'm trying to remember off the top of my head. I think it was 150-ish or something like that. But also that's something that you're going to keep for life, effectively. So Weller also makes some really great ones that are in that price range. I've also heard a decent amount of people reviewing that the soldering irons that are coming out of China are better. You know, they're a lot less, but you know, they may not last 20 years. They might only last 5 years or something before they choke out. But we'll, you know, I don't know. As far as the tips, I like to have a kind of a flat. I'll try and give you a better view of that, but it's not completely pointed. It's flat, kind of on the sides, but then pointed to a tip. It gives me the ability to get in pretty close into some of those holes, but then it also isn't too big that it's kind of in the way of doing things. That's my preference. I've heard some people that like to use other types of tips, like there's a type of tip that's round, but at a flat beveled edge. I think any tip that you become familiar with is probably going to work for you. Phanom, you are welcome. All right, so thank you for your comments, and I've seen some of your comments on YouTube as well. I appreciate those. Phanom one. Next up, we're going to put our capacitors in. Oh no, I want to do my jumpers first. So I need to have a jumper. Let's see. There's going to be a jumper that goes in the middle of this. Oh no, actually that's not a jumper. I just have not to drill the holes for those. So there is going to be a connection coming to that middle one, so I won't want to solder this because that has to come in from the transformer I just mentioned. So I will end up kind of soldering this bottom one. The bottom does connect from here to here to here so that we have all of our grounds tied together. And then I will connect a ground wire off of this so that I can connect that to a ground. So I will jumper these three together really quickly right now with some black wire. All right. Doing some of these little jumpers can be a bit difficult, but you get them done. I think I need a little bit more off. And then I left a little tooth mark in it, but well. The difference between mass manufacturing, I guess, and hand done is now you guys can see this end gets teeth prints in the wires. Alright, and then we'll do another jumper from there to there. And there's my pliers. There they are. Alright, now I will quickly, without turning the fan on, since it's just a quick one, I don't want this to fall out, I will quickly solder this in. Need a little bit more solder there. All right, there we go. All right, so I'll let that, I want to breathe that in. All right, so now I can put my capacitors in, and I'll be putting basically 2 in a row here. And I did find out that that is going to be a little tight afterwards, because these are decent sized capacitors. 1,000 microfarad at, I think it's 100 volts, no, 50 volts. So they're a bit big, but one other thing I always like to do with these is you want to face them so that the rating is visible from the top, so that somebody replacing them knows what values they're looking for. So I'm going to run these straight down, and we're going to end up a bit tight. So what I need to do also, part of that is I'm going to kind of lean it back a little so that the other one can fit in. Oops. Kicking the rocker rubber panel. I gotta move that somewhere safe. Alright. This also, now that I'm thinking about that, that will make it tricky for me to get a wire into that. So I'm going to want to be creative. I'm going to actually, if you look here, what I'm going to do is I'm going to bring this under a bit like that, which should give me the ability to give myself a little room, if that makes sense, because I need to get into here to solder something in. So this is on the back side less than optimal, but it does the job. And then when I put this one in, I will similarly on the back side, I'm going to actually give it a little distance, and on the front side I will fold it under a little and down. Now another common thing that I do with these, by the way, you want to be very careful when you put in larger size capacitors like this, because they can and will, because of their size, wobble more. That wobbling can create the wires to break over time. So you'll want to put a dab of silicone. The kind I use is GE silicone. I think it's 2, because it doesn't. The basic silicone by GE has some acids in it that will etch and do bad things to your component leads and your solder. So you want to use that kind that's not doing that. All right, so I will also have to kind of be able to get my screw in there. But all right, so I want to solder that center point. Oh, you know, I've just found a problem with this theory. I can't solder to the, oh yes I can. If I bend these down this way, I can solder them. But that does make that a little bit difficult as well. Since I just spun these up today, I would have made those a lot farther apart if I could have, because length isn't as much of my problem as the height. But now I'm definitely making that a bit trickier for myself. So, but in the future, if I do another build like this, I will make sure I am more able to give the room these capacitors need. Like I said, I don't want to solder oh, I actually don't want to solder that one in yet. I've probably tapped it a little bit, but that one is going to have a wire coming off that will go to the rectifier. So I'm going to get my, or not to the rectifier, but to the 12 volt. I'm trying to think of the term now. Not rectifier. It's 12 volt. Make sure the 12 volt stays consistent, and I can't think of the word off the top of my head. And I said it just a bit ago, but all right. So I'll just give a nice long lead here. That goes into there. And then I will solder that in. Alright, got that soldered. Similarly, I'm going to need to solder inside that, so I won't want to touch it, but I will tilt this back up. I do need to get myself a grounding wire coming off of that, so I'll give myself some room for a grounding wire. I seem to see no other questions, so I'll keep going. Alright, so my ground will come off of here. And we can solder that. Oh, come on. My solder wire wants to get in my way. There we go. Good to go. Oh, I just did a dumb thing. I'm now going to have to manually push this through because I need to put this one in as well. Getting in a hurry. Not thinking. All right. So I will get my soldering iron back up now. Get that to melt enough so I can push this down through. Alright, and I'll re-flow that a little bit again in a second because I don't think that will be a consistently good connection unless I come back at it. Alright. So we'll just, now that we've got that back in place, we'll solder this point. Oh, you know, hold on, let me look. I will double check because I think I'm seeing another wire that comes off of that point as well. Which goes, oh, that's the other part of the 12 volt supply part. So I will quickly run another lead there. We'll just use a different color since it's not like, this is going to be the other end of that device, so I'll be able to easily differentiate it visually. The 12 volt, anybody want to help me out there? Bueller? It's the thing that makes sure you have consistent DC voltage. It helps if you say you're putting in 13 volts, it will always output as long as you set it up right, the exact 12 volts that you're asking for. So, and for whatever reason, I'm totally drawing a blank on what it's called. Alrighty. Another thing you want to kind of be careful with these soldering, when you do solder things, is don't get your tip too close to some of the components especially. Resistors tend to be okay. Capacitors not so much. So you don't want the heat to stay too long. You get the soldering iron and stuff away as fast as you can. Just make sure you get enough. But that guarantees a better chance of not overheating and damaging the components. So I'm done with that one now. Let's go ahead and pull that out. And if we look, like the same thing I did before, there are two places I have to bring in here, and I have to bring two more places in here. So I've left those open, but we will go on the bottom, and we'll kind of make sure those are well bent before I snip those, but I'll first snip out all of the ones that I've soldered. Alright, that one. Then I will go to these other components that I have and make sure that they have a good bend around before I snip those off a little bit. You don't want them to be too close, and you can come back and clean up a little later, but you want to make sure that you get that excess, or that you get a good bend across there so that it's going to stay in place until you do connect your wires and solder them in. Now this is, this is one of the, this is the diode, but I think I've got that pretty well crimped in. And that is that board. Now, the next board to me is going to be possibly the most tricky because I had to do multiple things different. And I think I might also have missed a component for that somehow. But this last board is the FET board. Dumble has a board called a FET, which stands for Field Effect Transistor, and it is a type of an amplifier. It's a clean boost. The FET is used in this case, I've heard different stories. One of them I remember reading was that Dumble set it up as a means of allowing an acoustic guitar to go in and use the amp because you need a little bit extra boost for an acoustic guitar. And it's just a clean boost, but some people like it because you can also increase the amount of drive and gain you get out of the amp. I'm building it, and it's 100% solid state just in this little section here, so that part is a new thing for me. But the gist of it is going to be placing all these components in place. So I've got quickly, and the other thing though that's different that I did is I had to redesign the board a bit. The board that's on the Dumble already, if you look at the layout, was designed, and it was like an etched board, and you kind of had separate holes for each component, but because I'm really tight on space, I'm doubling up a lot. Like for example, there's a specific, I think it was a 1 meg resistor and then a 100 picofarad capacitor that are supposed to connect two of the same points, but they had separate holes for each one. Since I have eyelets, I will just be sticking them together. So, you know, the input that comes from there comes to here, and it jumps from there over to, I think it's this top corner, so I'll be connecting both of those there. And there's another resistor that jumps down from here, and then I have to put a jumper across to a different spot. So I'll have to put some wire jumpers down on that as well to make sure that those are ready. In fact, I just remembered I need to see my new layout I did to see. I wrote those wire jumpers on it so I can see it. I think I've got those. Oh, I don't have them down here. Give me about 30 seconds to run upstairs and grab them. I'll be right back. All right, I'm back. Sorry. So I will show these quickly on screen. This is my new fretboard layout, and it kind of maps to this. But I have to do a few jumper wires to kind of connect things. These are off to ground, so I will be connecting. Those all connect to a ground. But I'll probably connect the ground off to this side. Then we have the high voltage input that comes in here. We have I'll put my capacitor across here because that shares a connection of some of the high voltage inputs to the other areas as well. So, you know, I just want to have that visible for me so I can look at where the jumpers go because I'm going to do those first. Let's see, I don't see new questions of any kind. So that's good. All right. Okay, so next up is to do those jumpers. So the jumper for the higher voltage, I will intentionally use a red wire. I like to use red for anything that's carrying like some kind of like a V plus or a higher positive voltage. Black for my grounds. This one is going from this one to this one, so it needs to be about that long. And then signal wire that can just use random different colors. Heaters, I like to, some people will always do the same color for heaters, but I like to kind of have them different colors because it just looks nice seeing let's say a green and a white or a green and yellow. So that's me anyway. Alright, I kind of did overkill on that lead, but that's okay. The reason these need jumpers is that on the other designed board it had already designed traces that would kind of connect these points together. So if you look at that schematic, you'll see there are a lot less points on the board too, like I said, because I'm just going to be sharing the same eyelet holes for some things. And I've got all the components I need for that. Should be here, except like I said, I think there was one that seemed like I was missing, and I don't remember what it was, but when I was prepping this earlier today, I seemed to be short one. So. Alright, next. I think what I might, I gotta finish the other ones. So there's another one that ties all of our grounds together, so it's gonna go from here to here. But there'll be another one around to this one, and another one around to this one. So I've got to get all those done. I'll do black on those because those are my ground. Alright. Now these four central holes are going to be for the FET itself, and I will be putting that down in, and it's going to be narrower, and it has kind of four smaller leads, but I'm just going to be pushing it down into those as best I can, and there will be a little bit of flexing going on those leads to get it in there. But all right, there's that one. Now we need one that's going to come around, and I'm going to bend this one around a little bit because it comes from this point around and down, so I can just basically make sure I have enough. So kind of bend it around. All right, let me make sure there's no other questions of anyone. Looks like not. All right. Next, one more lead. And this next one comes from here to here. There'll be a slight bend that, but not as much, but I just want to get a clear away. As you can see, the reason I'm bending them those ways is to keep them as far away as possible from the actual other eyelets, because I'll be soldering. I could accidentally overheat something and then melt something, and that would be bad. So, all right. This is okay. So these three here are going to be a variable resistor that will go in here, and I might have to fight those a little because I didn't know the exact size of those, but we'll get that in a minute. I might have to slightly bend those leads away. I don't know if that's a good idea, but that's what I gotta do. Alright. Okay, so now those are all in. First thing I guess I should do is I have to figure it out exactly, but this is my FET. And this is one of the, actually oddly enough, kind of a fairly expensive piece. It was like about, I don't know, like $8 or $10 I think, just for this little FET. But so, the way I've seen it on the picture is there's a little tab, a metal tab, and you can possibly see that there. That metal tab needs to go basically down this way on the board. So I need to try and carefully flex these pins out a little bit. Try and use my pliers maybe here. According to that drawing, and I will double check, I think the front cover also will confirm it for me. It says the tab, if you look down from the case, I think from the case is near the tab, and then you've got source. I don't know if that's probably not visible. All right, so I'll double check this, but you can see on here it says source, drain, and gate, and then the bottom is case. So, and the case is the one below slightly the little tab, and the case is the one that goes to ground. Now this one here, actually, part of why that's there is there's going to be a small, like, I think I remember if it's a resistor or something that goes between there and there. And it might also be a small tantalum capacitor that is jumpering from here to here, so that that will work. But so my first thing is going to be to try and get. This is battling me. I've got to get the legs exactly right. All right, there we go. I think that got it. All right, so there's the FET in place. Now I just got to start getting some of these other components. So, as I mentioned, I have to be very careful, but I had hoped that the spacing of these two tabs would line up with those, but they don't. So I've got to see if there's a way I can gently pry them sideways without damaging things. These are designed to do what's called snapping in, but because I don't have the means of guaranteeing those types of things, almost there. Oh, that bent a little too fast. Hopefully I didn't just ruin that. We'll see. Alright, so that is almost there. Just got to be very careful about this, but okay, I think I have that where it will work. It's resting on it. I will have to be very careful, and I might just hold that back off for now, but that fits. So let's start putting the other components on here. I need 150K. Actually, what I'll first put on is I've got a capacitor that connects. Basically, it goes from here down to ground, and that's why I've given it a lot of rooms. It'll fit across there. Then I've got a 150K resistor that will go there. That does some dropping. The main input voltage comes in there. So, and that means this guy, 100 microfarad, 50 volts, will go right here. Next, let's find that 150K. So I have some tantalum capacitors. Those are going to be the ones that are going around this guy, but we'll get those in a minute. I need 150K. There it is. So this is a 2 watt 150K that will be able to take the a little bit higher current and dropping that it needs to do. It comes in. So that is going to go from here to here. Alright. And what I can do, I'm trying to think, I think I can probably tack solder that guy in. Look, I need to... No, so the 150K will basically come in here and then it'll come to there. That provides a high voltage filtering, but then that, is there anything? Oh, I might need to jump something across there. Remember, let me look. There is a 10K that goes from there. Oh, that's why I have this jumper, actually. So there's a 10K that goes from here to here. So let's see, do I have the 10K? It's 8.2K. There's my 10K. So I need a 10K that will jump from there to there. So hopefully this is kind of making sense that a lot of this is, if somebody's built you a layout like these, it's just a very complicated puzzle, but it is there are still some techniques that you have to kind of practice and hone, and that's why, you know, a lot of people will suggest if you want to start getting into doing some of this work, first start with pedals because they work at lower voltages, they're less dangerous, there's a lot less you can do that's expensively wrong that way as well, but you can at least, you know, learn from that as well, and then move on to some simpler amps, something like a Champ or a you know, a basic Marshall, you know, not trying to do any mods or tweaks to it, just the basic Marshall kind of standard tone that everybody loves in the basic Marshall. And then as you learn from that, you can work on going to even more complicated builds. All right, there's my 10K in place. Now we need, I think that's a 1 meg and 100 picofarad. Let me look at my schematic. You just got to quickly check. Yeah, 1 meg and 100 picofarad. And I think my 1 meg is right over here. There's the 1 meg. So this is what comes in from here down. Oh, sorry. I think the 1 meg and the 100 picofarad connect to the, from the gate, which I think is this pin, over to the input, and then there's going to be another one there, but let's look at that and double check. Okay, yeah, so the gate, which one is the gate? Down here. It's hard to see. Let me look. This is the part I'm nervous about because I could very easily mess this up. It is hard to see on the actual original layout. I'm looking at schematic. This actually, if I'm looking at this right, I may have to double check. I'm a little bit wary of this. So the part that's confusing me is I just did the 10K. That's supposed to connect to the drain, which according to this, oh, I might have the, no, it'll still be, I'm trying to decide, this might be the bottom view that I'm seeing on this picture, I don't know. So, this is the source, the gate, and that would be the drain. But that is saying that it connects to the 1 meg connects to the gate, which I am not sure which is the gate, but it seems like it's, it almost seems like it'll go from here to here. And the 10K that I just put in connects to the drain, which maybe is this one. Is that the drain? That is the drain. Okay. So these guys are going to jumper across to there. I think that's correct. All right. So I'm not going to solder these in until I do a little bit more offline double checking. But so this goes, I believe, from here to here. But I will double check later offline. And then that means I also need to put my little capacitor here. Oh, I did not take the time. You guys get to see me do this really quickly. This doesn't take long. I'm going to fire up my Rigel scope, and I'm going to do a quick testing of which end is the signal end. You want to find out what is the foil end of the capacitor to make sure you can guarantee the noise is sent away from the next stage. So, all right. So, what you do, let me see, I might need to see if I can zoom out a little bit and readjust the view to see this. I've done these on a lot of videos, but we're going to adjust our view. Oh, of course, it's got massive glare. We'll adjust that a little. Let's see. All right, there you go. So, right now, this is being a really big antenna, and it's picking up some kind of noise in the room right now. You can see that. I'm going to dial that down a little bit. So, you can see how much that takes up. I'm going to lift this up, and you can see I'm holding it on purpose so I become somewhat the antenna. I've got ground on the side, and then I've got the positive on the other side. All you do is swap these and see which one is lower. That one, I think, was a tiny bit smaller. It can be tricky. Sometimes it's really obvious, sometimes it's not. And I think if it's not, then you have a little bit better quality. So I have to almost, maybe I'll zoom that. Okay, so that's kind of at the outer edges of the scope range right now. We'll swap it if it goes out of the scope range when I'm done, or inside of it more. Oh, that's smaller. Okay, so that means that, really quickly, I can mark the end. I'm not going to undo it because I want to show you what I'm doing next, is we'll pull this back down. Sorry, things like I need to oil my thing here. We'll go back. So basically, now, if you look, now that I've got that black lead, I marked, oh, I do have a mark on that, must have done it ahead of time. I marked with black magic marker right here that was my negative end. So, what you want to do is, with this particular part, it's the input. That means when I connect into here, I'm connecting the signal from the guitar. That is the lower input inside because it's going into the inside of this FET to be magnified. So, that is the gate, which is the input. And according to this, if I'm looking at this drawing right, that is the gate. So I want that black dot away towards the source of the input, so I'll be putting it this way. Alright. So that's done there. Next, I need to put a what is it? I need an 8.2K and a 100 microfarad 50 volt that connects. Oh, you know what? I think I put the 10K here, and that 10K is wrong. That goes over. Let me think. That 10K connects between this point right here, and I think it might come over here. Is it? Or maybe it's, where is it? 10K connects into the drain, which is up there. So I did that wrong. So let's pull that really quickly. Alright. It comes out. And it comes over to here. Is that the drain? That is the drain. Like that, because then I need to put these next to, which will be these two capacitors, one of these two capacitors, and an 8.2K resistor. And I checked these as well by testing in tantalums. It seems like there's a little bubble end. That is the outer foil end. So for that reason, on this one, it goes towards ground. So that will go basically, let's see. Those are going to come off of here, and that's why I have a ground jumper here, because I'm just going to connect them here and down. This connection is getting messy. So now I need to put one of these 8K resistors in. And 2 of them total. So because again I don't assume that they have these always right, someone could have sorted them wrong. I'll quickly turn my multimeter back on. And double check the resistance ratings of these. I forget, I can't hold it on the end because it kind of causes my finger to create weird resistance. Oh, come on. 8K. And 8.2K just means that it has to be within the tolerance range. So that's like almost 8.1K, both of them. I'm going to leave 1 for right now. So that one will also go in this same spot. I think I might have reached max capacity in that particular hole. Alright. And then the last one is we get another 8.2 and 4.7 that goes from one to ground, which is the source. Which is that one. I'm guessing that means I need those to go from there to there, because isn't that jumper to ground? It is jumper to ground, so they're just going to share this common ground. But I also didn't give myself a whole lot of room, so that'll be a bit tight. But I think we'll be able to do that. Same way there, my ground is here, so this one will go. I'm going to probably do a bit of what I would qualify as I will give myself some slight leads. Alright, this. And I'm going to have to be careful because I do not want leads touching each other inside there. So that looks good. Similarly with this one. I can make this one quite small, luckily. And there we have it. Alright, so I don't feel comfortable soldering that yet until I do a little bit more double checking, but that is now a fully populated, ready to go FET board if I did everything right. So I think that will probably be a good stopping point tonight. We've got an hour. I will give, I guess, a couple seconds if anybody has any other questions before I close down the live stream. But I hope you enjoyed seeing me put together a couple of boards quickly here. We've got, we now have, as I said, we've got the FET board. I've got my rectification and bias board, and this power supply doubler for the foot pedal and jumper and not jumper and the relays for the foot switching. So thank you everybody that has joined and watched. Anybody that watches it afterwards hopefully will also get a chance to see what's going on and enjoy it as well. Please do comment. Let me know if there's anything else I could be doing in these different and better. Let me know if there's anything else that you want to see in the future. And please give me a thumbs up, subscribe, and tell people about this, because I do enjoy doing it and hope that more and more people will be able to find out about it. So I believe heavily in sharing of information so that we can all learn something hopefully valuable here. Thanks everybody. Have a good one. I'm not seeing any questions pop up, so I will call that a show.